Hi everyone, my name is Renjie Zhao, a PhD student of UC San Diego. Today I'm going to introduce our work on NFC Plus, breaking NFC networking limits. This work has been done during my internship at Alibaba Group. Today's major internet companies are transforming traditional e-commerce into a new model that is called online to offline commerce. Over the past few years, we have witnessed the great success of many companies following this transformation all over the world. As one of the largest O2O companies in the world, Alibaba Group owns many subsidiaries such as Cainiao, Hema, and Ele.me, which covers O2O services from not only in logistics, but also in new retails such as food and grocery delivery. Based on the operating experience, we found that the core problem people face in the ever-growing O2O services is how to do efficient object identification at large scale. Now, let me explain to you why we need to do object identification effectively. Take Cainiao logistic network as an example. The product purchased online had to be delivered as soon as possible through a logistic network to arrive at customers' hands. In this scenario, we need to identify the package in almost every logistic operation in order to route it to the destination. Today, you can usually see a label like this attached to a package delivered to you, which is for this purpose. However, the flow of logistic network today is becoming extremely large. For example, the total delivered package number of Cainiao Smart Logistics Network is 30 billion in 2019 and is expected to be 150 billion in 2025. To meet the demanding scale and efficiency challenges, we can no longer rely on traditional barcode and QR code, which becomes slow, labor-intensive, and error-prone. To solve this problem, UHF RFID has been widely acclaimed to be the vital enabler for object identification. But what we see is that although UHF RFID has been there for 30 years and after numerous trials in real-world deployments, it only finds its use in very specific application scenarios, such as apparel retailers. What is the problem? After talking with many vendors and logistics service providers, we found that the main issue of UHF RFID is on the reading accuracy. Consider this example. A worker is using trolley to bring 20 labeled packages out of a warehouse. The trolley will first pass a tracking zone to make sure he got everything correct. By using RFID, worker will not need to scan the labels manually. The reader in the tracking zone can do the detection automatically. There can be three kinds of reading result. First one is all of the tags are detected, which is great. But life isn't always perfect. Sometimes there will be 19 tags detected, which means misreading happens. And sometimes there will be 21 tags, which means cross-reading happens. Both results may lead package lost and introduce significant verification cost. This problem really handles today's RFID deployment. To understand the problem, we need to take a closer look. UHF signal will be attenuated by most objects, which leads to misreading. Also, because of the multipart effect, the signal strength at a long range can be very large, which introduces cross-reading issue. Because of these reasons of misreading and cross-reading, we see that the accuracy of UHF RFID is only around 90%. We have talked with vendors, logistics service providers, and the manufacturers. What they expected is an accuracy of higher than 99.9%. The 9.9% difference may lead to billions of dollars lost for handling misdelivered packages. Many vendors even discard the RFID setup after deployment because they do not see any benefit with the low accuracy. Therefore, one thing we want to emphasize here is that in the real-world deployment, the median error or even 90% error make no sense. The tail error is the most important issue and hard to reduce. By analyzing the reasons, we found that the main issue is on the physical properties of the signal. Any algorithm-based technique will not solve the basic issue introduced by the physical properties. because it is mainly determined by the frequency. Therefore, we choose to change the mind from struggling with the UHF RFID electromagnetic wave to find some other replacements. What we found is that the NFC at 13.56 MHz with magnetic wave has much better properties. Unlike UHF signal, NFC signal will not be attenuated by most objects. Therefore, the NFC will not meet the misreading issue introduced by object blockage. Since there is no multipath effect for magnetic wave, there will also no cross-reading issue for NFC. Because of these properties, it seems that NFC is a perfect solution compared to UHF RFID. However, it also has its own issues, which is the reason why it is not adopted, even it has longer history than UHF RFID. The issues of NFC is on range and orientation. Because the magnetic field attenuates much faster, the typical reading range of NFC is really short. For example, the commonly used portable NFC module only covers several centimeters. Even the longest NFC today will only cover 90 centimeters. Then, since the magnetic field is closed-loop field, the orientation of tag will influence the strength a lot. For example, when the tag is perpendicular to the field, the tag signal is the maximum. If the tag is parallel to the field, the tag cannot be read. Because of these two issues, the NFC technique is mainly limited to proximity applications. To fundamentally overcome these barriers, we propose NFC Plus, a system that solves these two issues simultaneously. It is the first system to enable NFC in logistic operation. It extends NFC communication from several centimeters up to 3 meters. It is compatible with ISO 15693 protocol and can work with commercial NFC chips such as MiFire family from NXP. It is very accurate with an accuracy larger than 99.9%. We realize NFC Plus through multiple innovation thrusts, including resonance engineering, new self-interference cancellation in transceiver, magnetic beamforming, and magnetic repeater. For the interest of time, the details of the techniques are skipped. Please refer to our paper and the 20 minutes video for more information. We have built a customized reader. The hardware design contains a multi-channel TX module, self-interference cancelled RX module, and an STM32 ARM processor. The coil of the reader is a 0.9 meter by 1.1 meter gamma loop, and the tag we used is a commercial ISO 15693 NFC tag. For the software, we implemented the ISO 15693 compatible protocol in C++, which contains multiple access and collision avoidance functions. It offers a reading rate of 50 tags per second. Here, we will show a lab demo representing the logistic network case. In the region, we deployed 2 TX cores and 2 RX cores covering a tracking zone. 16 NFC tags are attached to some most RFM-friendly items, such as bottled water and Coke, canned Coke, and boxed milk. The items are placed on a trolley with random orientation. The trolley is pushed through the tracking zone, and the UID of tags are read. By comparing with the ground truth, we can get the misreading number and the cross-reading number. The accuracy result is shown here. You can see NFC Plus only misses 0.03% tags and doesn't cross-read any tag outside the tracking zone. It performs much better than NFC and UHF systems. In summary, NFC Plus is the only system that covers long range with arbitrary tag orientation while achieving over 99.9% accuracy. We also want to give 2 take-home messages. One is that the tail error is crucial in real deployment. Researchers also need to keep an eye on this. The second is that we want to bring magnetic communication back to researchers' side because the physical property of magnetic field is extremely superior in many large-scale applications. Thank you for your attention, and we are happy to take questions.
Okay, thanks a lot. I am checking if I see the speaker. Hey, there we go. I'm going to kick it off with one question. So one of the things I really like about this work is that you're tackling a very real world problem and you're trying to improve the way we do it by switching to magnetics instead of RF. But I'm curious, in making this practical, like, are those coils, they're manufactured out of a material I wasn't aware of. I saw the name in your paper. It sounds like a futuristic material. Is that material hard to find? Is it expensive? Are there a few manufacturers? Like, how practical is using that material?
Yeah, so the thing here is that at least first, the core we are using that is pretty available now. So for the reader side, all the things has been ready there. And for the tech side, what we are using, they are basically the commercialized ones. So basically they have been available in the market and we can just pick out those things to use in our system.
Okay, and I'm curious, was this material used in the coils of prior RFID or NFC readers, or, you know, what was the prior application of that high Q material before this?
Yeah, so this high Q, it is not mainly limited by the material. So what it happens is that it is just using some kind of metal. What we use is just aluminum. And this coil, it just need to bond as a coil. And the high Q, it was mainly introduced by the low resistance of this coil. You know, because it is just a metal and the resistance is low and the internal quality factor is pretty high.
Gotcha.
So
we have another question just to keep things moving. This is from Tong Li, and he said, just curious, you know, how much is the NFC Plus more expensive compared to your standard NFC deployment?
Yeah, so for the cost here, I think the main question is on the reader side, right? So for this question is that we have two cores and the same reader. And what we are doing, maybe the basic hardware cost, it is beyond, no, it is lower than $100, no, $1,000 for our prototype. And the main cost is on the power amplifier there because we build the whole prototype with discrete components. And what we expect is that after we have make it integrate all the things together, and after mass manufacturing, this cost can be cut a lot.
Okay, great. And last quick question, are there any materials when the coil is mounted to that would cause any sort of, effects that would make the coil not work as well?
Yeah, so what we have done here is that what we test is that we have using those items on the trolley and passing through the tracking zone over there. And this doesn't, at least so it is working well for this environment. And sometimes this material might influence the coil because we are using a high Q coil over there, and it is somehow sensitive to the environment. But we can also introduce a technique which is called auto tuner. So this one has been well studied in the magnetic communication field, and this will work for the tuning for the whole system.
Hi, Renjie. Yeah, very nice work. Yeah. So let's see. I have a basic question, a very high-level question. So actually, I think it's a very interesting idea to use NFC, the magnetic, to do the communication instead of this radio. But what is the limitation if you compare with this one? So is that automatic solutions, or still have some issues unsolved?
Oh, okay. So so basically, what we want to do is to leverage the good property of magnetic wave, and the main issue is what we try to solve, the orientation issue and the range issue. So at least in our deployment and in our case study setup, we found that it works much better than the UHF system. And currently, what we still need is somehow the whole system, I would say, integration, something like that, because what we have done is still on the, it is just a prototype, and we really want to push it to be a product which can be available, can be deployed in the real logistics network, and also for other researchers for the further research topics. Yeah.
Okay. So if, how about this metal? So it's a if this things I packed by, for example, this metal box, or is so is magnetic is better to penetrate this metal compared with radio?
Yes, yes. So the thing here is that many materials, such as metal or liquids, will can influence a lot for, I would say, our signals, and that is main reason why UHF signal won't work for most of the case. And for magnetic wave, because most of the materials, this magnetic wave will magnetic field will not be attended, influenced by most of the materials. For example, all kinds of the liquids, and also for some kind of metals such as aluminum. So this is reason how this is the main reason why we can use this NFC Plus with those CAN-code, those kind of packages items. And one possible issue there is somehow the material that this kind of metal can influence a field to the tag, because the tag also need to keep as a resonant frequency so that it can be read at a long range. This resonant frequency can be shifted a little bit because of adjacent metals. But this is also a well-known issue in the NFC tag design. So therefore, currently there has been some tag, which is called anti-metal tag, which is trying to solve this issue. And more simply, we can just choose to increase the distance between the tag and the metal so that it will keep working fine.